Hello children, consider this sequence 1, 4, 9, 16 and so on. Are you able to guess the next term? Even if you aren't able to, just let us look at it and analyze it a little bit. This is our first term. We're calling it terms. We're calling each one of the entries as terms. And this 1 is our first term. So let me write here. First term. This stands for terms, right? And this is my second term. 4 is the second term. 9 is the third term. And this is the fourth term. So let me write. What does the first term stands for? It is 1 squared actually, isn't it? And this is 2 squared. And 9 is 3 squared. 3 into 3 is 9. 16 is 4 squared. Now we can easily guess the next term also. Now, if we recognize the pattern which is involved, it's easy for us to guess the next term. So this is 5 squared. So this is 25. And this is our fifth term. Let us represent each term by this symbol A1. A1 stands for the first term. The subscript stands for the position of the number in the sequence. So this is A2, right? Second term A2. Third term A3, A4, A5 and so on. Now why are we doing this representation? Just to generalize all of this, and in case you need to find the kth term, how will you find it? It's very easy. What is AK? Just like A5 is 5 squared, A4 is 4 squared. So AK will be equal to K squared, right? So you need not worry about your preceding terms or your succeeding terms. Straight away you can say AK is K squared. Or for any number n or the nth term, not any number n, the nth term an would be equal to n squared. And this is going to be our general formula. The statement of this sequence, explicit statement of this sequence. It is stated explicitly. So let us look at one more sequence. This time let's say the sequence is 1, 2, 4, 8, 16 and so on. So before you start guessing what is the next, of course you will be able to guess easily. Let us, as usual, list down the position, the terms, the position of each number in the sequence. This is the first, right? This stands for the terms. First term, second term, third term is 4, fourth term is 8 and the fifth term is 16. And what does it stand for? How will you guess the next number in the sequence? Just see that you are multiplying each term by 2. 2 into 2 is 4. 4 into 2 is 8. So you multiply the first term by 2, you get the second. The second term multiplied by 2, you get the third. The third term multiplied by 2, you get the fourth and so on. So our our sixth term is going to be equal to 32, right? So let me also denote the terms by A1, A2, A3, A4, etc. I am writing this in order to arrive at a general statement for this particular sequence, right? So how do we do it? Suppose I want the kth term. What do I do here? How would I find the kth term? It would be 2 times the previous term, isn't it? Twice the previous term, that is the kth term, or AK. In this case, AK would be equal to 2 times K minus 1, right? So what is A2? A2 would be equal to 2 times A1. Does it match our sequence? Yes, A2 is 2. It is 2 into 1. And what is A3? A3 is equal to 2 into A2. So this is correct. This formula which we have framed is correct. So what about the nth term? The nth term an would be equal to 2 into n minus 1. But one handicap in this kind of statement is you need to know, see, I have made a small mistake here. It is not 2n minus 1, it is 2a, the n minus 1th term, 2 times the n minus 1th term. So you need to know the n minus 1th term in order to find out the nth term, right? Without knowing what is the n minus 1 term, you cannot find the nth term. So suppose I ask you what is A82 or the 82nd term, you will be able to tell me it's 2 into 2 multiplied by A81, but we don't know what is 81, right? So now again we'll have to know what is A80. So it is going to be equal to 2 into 2 times A80, and it's going to go on forever. So let us try to write this in some other way. This pattern, this sequence, the pattern of this sequence, let us try to represent it in some other way. Just think, how can we do it without involving the preceding term? That is, the nth term should not be dependent on the preceding term. So can we do it? Now let me rewrite the sequence here. It is 1, 2, 4, 8, 16 and so on, and the terms here. This is the first term, the second term, third term, fourth term, fifth term. So observe that we are multiplying each term by 2, right? Right? So this is 2 into 2 and this is 2 into 2, but this 4 is already 2 into 2. So can I write it as 2 into 2 into 2? So it looks a little clumsy. I mean, you can't even guess what it is. So I can write 4 as 2 into 2, and again I multiply by 2 and I get this. So this becomes 2 into 2 into 2. And here one more. Like, can I write it as powers of 2? Isn't it? So 1 can be written as 2 to the power 0, right? So any number raised to the power 0 is 1. 2 can be written as 2 to the power 1, and this is 2 squared, this is 2 cubed, 2 to the power 4. Now I think we can arrive at some general formula for this particular sequence. So what can it be? What is AK? What is the kth term? AK would be equal to, now we'll have to look a little at what is A2 now. Before writing what is AK, let me see what is A2. A2 is equal to, is it 2 times A1? That is A2 2 times A1? Of course, yes it is, but I wanted to know a formula which is independent of the preceding term. So what is A2? It's 2 to the power 1, right? 2 to the power 1. So, and what is A1? It is 2 to the power 0. So if I go on in this way, I can say AK is 2 to the power k minus 1, right? Or AK is 2 raised to the power k minus 1, or the nth term is 2 to the power n minus 1, right? So we have arrived at some general formula for this particular pattern sequence. The pattern in this sequence is the nth term can be found by doing 2 raised to the power n minus 1. Suppose you want to find the 80th term, you can just write A80 is equal to 2 raised to the power 80 minus 1, right? So it is 2 raised to the power 79. You can directly find what is the 80th term without having to depend on what is the preceding term, etc. So this is a formula which has been stated explicitly, whereas the previous one depends on the, where is our previous formula? This one depends on the preceding term. This one does not depend on the preceding term. Of course, both these are used in different purposes. I am just writing different ways of representing the sequence. Not that this is wrong. This is also used, we'll come to know later when we do further in our later videos. We'll come to know where this kind of an expression is used and where the other one is used. Now, so this is clear to us. I hope it's clear to you also.